In this video, I'm going to introduce the concept and the syntax around the SQL select clause, which is kind of the foundation, or it's always a part of a SQL query. You always kind of start with, well, not necessarily always start with, but typically you're starting with a select. You're basically telling SQL, what do I want? What do I want to see? And so you're telling SQL select this for me. And so we'll dive into the PowerPoint here. And to recap on the SQL query, which was introduced in a prior video, prior lecture, it's comprised of 6 primary clauses, and the select clause is the first of those, presented in this example query in the top right. So we're telling SQL to give us certain things in the select list from a table, and applying filtering and grouping criteria, and also sorting criteria, and that's really the nuts and bolts of the SQL query. And again, just to review, the queries themselves are usually transactional. They're not going to impact the data. There are, of course, ways to update, change, alter data. In a work environment, you might be restricted from doing so by only having read access. And so this is really, you're just telling the basic of the query, or the foundation of the query is just telling SQL to give me data and give it to me in this form, with certain manipulations or modifications, and that's it. But that's not to say that the SQL language doesn't have a lot of complexity and a lot of nuance, because you can ultimately do a lot with it. And there are thousands of lines of SQL code at the end of the day, even though a query looks just like this. And it's all, generally that code's using a bunch of these kinds of queries. So diving into the select clause, in the example that we showed above, the select clause is the first. And in this particular example, we're telling SQL select count star, and then select also the field city. And so each one of these elements in the select list is separated by a comma. The select clause always begins a query, and is followed by the elements you're selecting. So in this case, we're selecting a count, kind of an aggregation function, and then we're also selecting the field city. And SQL will return anything that you're selecting in a query to the output window. So we saw this when we did basic calculations with the select clause in the prior video, prior lecture, right? Select 3 plus 1 will return 4 to the output window. And another example, using data in a table, select city will return all records for the field city. So you'll have in the output window, you'll have a column called city, and then each record would display the value for city for each record within the larger data set. The select list is ultimately separated by a comma. Each element in the select list is separated by a comma, but it can be comprised of a few different things. The standards are, just a field from a table. So in this particular select list, and the second element in the select list is the field city. They can also include aggregations of fields from a table. So for example, if you have a field called revenue in a table, and maybe that data is ordered by customers and by a particular month, you can tell SQL, hey, give me all my revenue from February 2020, and that would be accomplished through an aggregation function, particularly, or in particular, the sum function. And so that can be included in a select list. And then anytime, just kind of a preview of the future, anytime that you use an aggregation function, in addition to aggregating across a field, you will need also the group by clause. And that's why it's present in this particular query. But we're only focusing on the select clause to start here. And then ultimately, so you can pull fields, you can pull aggregations of fields, or of aggregations of values from those fields. And then you can also modify the values within a particular field. So say you have in a data set a field or a column that has the first name of a customer, then another column that has the last name of a customer. You can ultimately combine those into a single field in your output through a select through a select clause. And that would typically be accomplished through concatenation, which is the joining of string or word character data. And then ultimately, there is the select clause, but you can modify it in several ways. The first is essentially with a top keyword. Select top will restrict the number of records returned by SQL. In this particular example, we're saying select top 10 city from this person.address table. And so what this is telling SQL to do is return the first 10 records for the field city. And so what you'll essentially see are 10 rows, a single column, and then it'll have, in each one of those, you'll have different values for a city. So in the first row, you might see Cincinnati, and the next one, you might see Pittsburgh, and those are the values for the fields, for the field city in the first 10 records that are returned. I will say that the parentheses, I'm sorry, I'm clicking on these and it advances the slide. The parentheses around the number here, top 10, these are optional. Personally, I don't use them. I just included them here because a lot of examples you see out there, they are included, but they are optional. I've never encountered an example where you need it. So that's the top keyword, and you'll see that used quite a bit in everyday querying. The other kind of modification to the select, or kind of a special case for the select clause, is select star or select, and this is the asterisk symbol. And what it does is it returns all rows for all fields. It's basically telling, in this particular query, select star from the person.address table. It's telling query, hey, SQL, give me all fields and all records from this particular table. And understandably, if you want to look at a data set, what does this look like? Well, yeah, I'll do select star right on the table, and it is useful, but it's generally not advised to use the star in this, or the asterisk symbol in this particular way, because if your data is large, say thousands or even tens of thousands, or it's really going to start to become an issue when it's more hundred thousands and particularly millions of records. You're basically going to, when you run this query, you're going to tell SQL return all 1 million records to the output window, and you'll start to strain your own computer memory. I don't think it would really strain the server side too much, but it is ultimately very inefficient to use a query like this. And so really the easy way around that is to use the top keyword in addition to the asterisk symbol. So in this query here, we say select top 10 star from the person address table, and that tells us select the top 10 records for all fields in the person address table. And so we're going to kick over to SQL just to view this in practice. So I already have my connection established. Let me zoom in here so that this is more readable. I don't know that I can zoom in on the Object Explorer in the same way, but I'm ultimately connected to my server here. I've got my database connection, AdventureWorks 2019, and so I've copied this information directly from the PowerPoint, and you'll start to see some red squiggly lines, and those are on by default. They're basically telling you that you have a syntax error. So something here, the way that it's written, is wrong. And so if I were to highlight and run this query, so highlight, execute, or you can press F5, I'm going to get an invalid object name, AdventureWorks 2017.person.address. And so what I did was I was running this code on a different computer that I have, and it ultimately has a different version of the AdventureWorks database loaded on it with a different database name. So you can see here the database reference is AdventureWorks 2017, while on this particular computer, I have AdventureWorks 2019 installed. You can rename this if you really wanted to. It might save you some typing in the future. But really, it's basically, you might have to do this with all the examples that I'm showing, depending on the version of AdventureWorks that you have. So I'm going to change that to a 2019. you'll see the squiggly lines didn't go away immediately. So it does take sometimes SQL a few minutes to recognize, or longer than you would normally expect, to normalize, to recognize that the syntax is now correct. And so now that I've updated this, we're just going to run it. So this is using the select top keyword. So this was the first example. And it's going to basically turn the first 10 records for the field city from this table. We might ultimately, well, we did see differences. Sometimes, depending on the data, you might see the same value repeated for 10 times because all records have that same value, or the first 10 records have that same value for city. But you can see various city names here. And they're ultimately divorced from the other data that accompanies that record, because we told SQL return just this field from this data set and the values for this field for the first 10 records. The second example, and this won't blow up on you. I don't think AdventureWorks they don't have data sets big enough to really cause issues with the select star. But when you get to the to quote unquote real life data, right, that potentially is millions of rows long, this could cause an issue. So I'm going to run it. I'm going to move this. I don't know if I can ultimately expand the output window either. It doesn't look like it. So I'm going to run this query. You can see it took 2 seconds, I think is the time down here. So it didn't take long to return ultimately almost 20,000 rows. And so you'll see, right, that that this returns, well, first, we'll just start with the basics. This is telling SQL return all records, all fields from this table. And so we see all, 19,614 records are in this table. It takes a minute to scroll all the way through them all. And then all fields are also present. So these are all the fields in this table. And so this kind of gives you everything that's in that data, and it sends it to the output window. What I will note, right, is look at the first 10 values, and this is what I was alluding to in our first query. Ultimately, what we saw was something different, right? We didn't see these first, we didn't see 10 rows with the value Bothell for every city. For every record that was returned. And the reason that this is the case is that without an order by statement, without telling SQL how to sort, the sort order of your results are never guaranteed when you start to perform modifications to the table, including kind of a top keyword. And so in this particular instance, we saw different values for the field city. So just keep that in mind. And then when we ultimately select top 10, the first 10 records from the table, they're not guaranteed to be the same. They might be in this particular instance, but we'll see what happens. So this will be the first 10 records. They were I think the same records. So we'll run the first one, 1970. Yeah, it appears to be the same records. But if we were to say select top 10 city, which we already ran, right, we'll get different values for the field city here. So we'll run that. Yeah, we got different values. And this would also be the case if we look at the table. Let's just say we want more fields than just city. We want city, and also let's just call it address ID. And so we can add that to our select list separated by a column, and we'll run that. And we did get those same first 10 records that we saw in the first query, I believe. And you can see that the address ID that accompanies those is really selected from all over the table. And I don't have a great reason why. I know this is the way that it can happen. And again, the moral is that your results are never guaranteed, especially when you start performing modifications to the data. the sort order is never guaranteed without an order by. And I think part of it has to do is the way that the query optimizer optimizes the query. So in the background, I'm not a technical person. I'm not a computer scientist, but the compiler, and there's an optimizing kind of routine that SQL performs in order to optimize the query. And so the query that optimization might ultimately take different paths depending on what you're telling the SQL to do. So that pretty much covers, a couple different modifications to the select clause. And returning back to the PowerPoint, we'll go to the next slide here. The other thing to kind of that I want to discuss with the select clause, because this is where it comes up most frequently, is aliases. And in particular, I'm talking about column aliases for this, because this is when you use aliases in a select clause, it's typically for field names or column names. But an alias generally is just a way to refer to elements within a SQL query. So you can have a column alias, which will specify a field name in the output window. So if you recall, when we were doing those calculator examples in the prior video lecture, the output ultimately said no column name. So there was no column alias, right, attached to the output. There are also things called table aliases, which specify a table name within a SQL query. And usually those aliases are for the table references are confined to the SQL query and used to kind of differentiate one table from another, which is kind of needed when you're working with joins or combining two data sets together within a single query. And so just focusing on column aliases only, there are three ways to specify. One is, I'm sorry, press the click button. One is to just use the column alias as is. So you don't have quotation marks and you don't have brackets. So in the first example, right, you'll see select 1+1, and we're giving it a column alias of 1_plus_1. And we don't have any. We just put it right after the operation we're requesting, and that returns the field alias in the output window 1+1. And notice that there isn't a comma here, right? Because if you were to add a comma, that 1+1 would become an element in the select list and no longer a column alias. Then in the second example, we use single quotations. You'll notice that you have the same output for the field alias. And then in the third example, we use brackets. We use brackets, and that ultimately has the same effect for this particular field alias. And we'll get into why you might need one in one example when you might not need it in another. And then ultimately you can use be more explicit about the fact that you're giving a field or a field in the output a column alias by using the as keywords. So you see we introduced between the item we're selecting or the element in the select list and the column alias, we've introduced the as keyword here, and it ultimately has the same effect. But this code might ultimately be more easier to read, etc. It's not required. And then finally, to talk through, right, that, why are we seeing brackets here, and then why even single apostrophes? Well, SQL, in any programming language has special characters that when you introduce them into the code by themselves, it causes the code doesn't know how to compile them. So for example, a blank space in a field name reference, SQL encounters that blank space and it's already moving on beyond, it's not even thinking that this is a field name. And so it'll cause a syntax error. This also occurs in R, like with I can't remember if it's a backslash or a forward slash, but that's a special character that when used in a string or any that R will kind of interrupt and tell you, hey, I don't know what to do with this. And you can think of other special characters like exclamation points, which may or may not be a special character for a programming language. It is for T-SQL. Exclamation point. Trying to think of some of the others. A question mark. Some of the stuff you typically wouldn't expect to see in a programming and a code chunk, but can nonetheless pop up from time to time. It's more common, I would say, in T-SQL, given that the fact that you can have column names, table names with spaces, and I'm huge advocate of not introducing special characters when they're not needed or serve no practical purpose. But that's not to say that you won't go to work for a company and they've already got the data already set up, and guess what? Your field name, your table name might have a space in it. So now you're forced to use brackets. And why are you forced to use brackets? Well, ultimately those brackets escape the special characters. So it's telling SQL, hey, when you encounter a special character within 2 square brackets, ignore it and continue to process. And that's why ultimately the brackets allow you to process special characters in a table name or a field name when they wouldn't otherwise. And then finally, when there aren't any special characters, you're not required to ultimately use those brackets. And then looking at an example from the prior lecture or video, we selected a top 1,000 rows, and we did that by right clicking the table name in an object explorer. So if we go over, and we'll just do it again real quick. Let me exit out of here. Let's see, we'll go to the person.address table, and we'll right click, select top 1,000 rows. Right, and SQL automatically generates this query for us. You'll notice that it automatically puts brackets around all these fields, right? But in no particular case in this example are they required. So you could remove them from all of these. I say that, and then the address word turns blue. So let's just check it out. It should still run. Sometimes there are reserved keywords that wouldn't allow you to execute. Ultimately, address is a word that can be used in a query for different purposes. But because here at the table reference, SQL doesn't have an issue with it. So we remove some of the brackets, right, and the query is still going to execute just fine because there are no special characters within those. So that kind of concludes our video. We reviewed the high level SQL select clause, how to modify it. With a top keyword, and then also how the asterisk symbol it can be used in the select clause. We reviewed column aliases, and then also brackets and special characters.